Data security has become an important aspect in modern day technology. And that is why in this video, we are going to show you how you can be able to encrypt an image using Python programming language and the cryptography library. We did a previous video on how you can encrypt text data. And if you have not watched that video, click on the description below and then you'll find the link to that video. Watch the video. You can as well share it with your friends. So to start with, you import the requisite libraries. In this case, we need only three libraries: a cryptography library, which will house our algorithm, and the algorithm that we are using is known as Fernet. Fernet is a symmetrical cryptography algorithm, which means that it does encryption and decryption using the same key. Then we import the pillow library, which we are going to use to load our image as well as do other manipulations to our images. After that, we import the matplotlib library. And if you are a fan of this channel, you have noted that we usually use the matplotlib library for visualization purposes. You can as well use Seaborn, but I am more fan of a matplotlib library because it is the base library. So after that, you run the cell by pressing Shift Enter. Then you go ahead and load your image. So you first create a variable known as image. Then you call the method known as image.open. Remember, this image is the sub-library that we have imported here from the pillow library. Then you pass the name of your image. And just to remind you that this image must be saved in the same folder where you have your notebooks saved or where you are saving your work. Then after that, we convert our image into bytes using this function known as image.2bytes. And then we save it in a variable known as image underscore. Then we visualize our image. We are going to use matplotlib to visualize our image. So we say pl2.imshow. Imshow is part of the pillow library. Then we pass the image, which is the one that we want to visualize over here. We give the title, and in this case, we say that the title is the original image. And then we call plt.show to display our image. And we can see that this is the image that we have. It is the English Premier League trophy. So the next step here is now to first generate a random key, just like we did with the text data. The very first thing is that you come and you create a variable known as key, and then you call this method known as funnel.generate key to generate a key. Then you can create another variable known as funnet, and inside it, what you pass is the key as a function of funnet. After that, you come and encrypt the image. So you come here and create a variable known as encrypted data is equal to funnet.encrypt, which is the one that we have created here. And now we have called the encryption method. And then inside it, we pass a variable known as image data. This variable is the one that we created over here. You can be able to see it. So after that, we save the encrypted image to our folder, and we use the Python file input output operations to do this. So we first open the file, and then we write the file, and we'll save the image as encrypted underscore image.png. And then we can print the key for purposes of us seeing the key that we are using. And once we run this cell, this is the key that we are using. You can see that's a very difficult key for one to guess. Then we can plot the encrypted image. And once we plot the encrypted image, this is how it looks like. If you try to compare this one with the original image that we have over here, you can easily tell that when a person who doesn't have the key look at this encrypted image, they cannot see what it is. For instance, if you never wanted your Arsenal friends to see this image and encrypt it like this, they wouldn't know what it is. But now, once you perform encryption, your friends must also be in a position to decrypt. So how do you go ahead and decrypt this image? So the very first thing is to open the image and load it to your program. So you first open the image by calling the with open method. Then you pass the name of the image. And then after you load the image using the read method, you decrypt the image. So to decrypt the image, you just come here and create a variable known as decrypted data. And then you call the Fernet decryption function to decrypt your image. And inside it, you pass a variable. And in this case, the variable that you have passed is the one that is known as encrypted data. So this encrypted data, we created it here, as you can see, when we were encrypting the image. So now we want to decrypt, we want to reverse the encryption that we did it. After we do that, now we create an image, we create another variable known as decrypted image. We call now our decrypted image. And now this one will convert this image from just encrypted data into a normal image that has pixels that we know about. Then you can be able to run that particular cell. Let us now display our decrypted image. And once we display the decrypted image, we can see that it looks exactly like the original image that we had encrypted. Let us now go ahead and display the three of them so that you're able to compare. You can see the original image over here. You can see the encrypted image over here. And then finally, we have the decrypted image. So this is a very easy way for you to encrypt your images just for purposes of securing them. Remember, you can be able to share that key with your friends so that they are able to decrypt the image from their edge. And I believe that today you have gained something. So thank you so much for watching this video. Please continue subscribing to the channel as well as like our videos. Put your comments in the comment section below and also share these videos with your friends so that they can as well benefit.